Okay, this is a quick review for the Unit 9 extra credit test, starting with 911. Okay, so with 9.1.1, one of the first things you have to be able to do is just add, subtract, multiply, and divide rational expressions. So just very quickly with that, remember that when you're dividing, right, dividing and multiplying are pretty much the same thing. The difference with dividing is that you have to keep the first fraction and flip the second fraction and change it to multiplication, and then it just becomes a multiplication problem. So we'll just do a divide real quick. Adding and subtracting are also similar, so we'll talk about those in just a second. So when I'm looking at something like this, a couple things that need to happen. One is that I have to factor everything, and the other is that I need to change that to a multiplication problem. So I'm going to kind of do both at the same time. So factoring these things out, the top part there goes to x plus 3, x plus 2. The bottom here, that would be x plus 8, x minus 3. Right, because negative 24 and then 8 minus 3 makes 5. And then we're going to change this to multiplication. So this is actually the top right here is going to be this one right here. So this factors to x minus 5, x minus 3. And now this one, right, so that's this one. And this one's going to go to the bottom, which is going to be x minus 5, x plus 2. Right, so we kind of did two things at once. We factored and we flipped this bottom fraction. So the bottom became the top and the top went to the bottom. Once you're here, you're allowed to cancel anything on multiplication and division. So as long as they are the exact same terms, so like x minus 5 and x minus 5 can go. I've got an x minus 3 and an x minus 3, they can go. I've got an x plus 2 and an x plus 2, those can go. And it doesn't matter which fraction it comes from as long as it's top and bottom. That's the important part. You can't cancel bottoms together because the whole idea is that when I divide these out, it creates 1. And it's not true if it's on the bottom. It doesn't create a 1. So once I get everything canceled out, whatever's left over is my final answer. X plus 8. Alright, that would be the final answer. Be careful not to try to cancel x's here because there's a plus 3 attached to that one and a plus 8 attached to that one. This x is also being divided by this, and this 3 is also being divided by that, so you can't just reduce the x's. It only works if they're factors. You can cancel factors. So that is division and multiplication. Multiplication, you just wouldn't do the flip step. Okay? Adding and subtracting. When you're looking at adding and subtracting, you're talking about making sure that you have common denominators. So for instance, something like this, right? And we talked in class about the fact that you can't just like add a 4. The only thing we can do is multiply. And multiplying by 4 would give me 4x, not x plus 4. So in order to create that common denominator, this one over here is going to need the x. So I'll multiply that to the top as well. And then this one here is going to need the 4 plus x, which I'm going to rewrite as x plus 4 because I don't like it being backwards. Alright, and I'm multiplying that whole thing. Okay, because these would be the same denominator. So on top, I'll multiply that out. X squared minus 5x. I'm going to leave this as x times x plus 4. And then minus, I'm going to multiply this out as well. So 3x squared plus 12x minus x minus 4. That's just foiling out the top there. Oops, don't need that. Over x times x plus 4. Alright, and then make sure here that you distribute that negative. So this is going to become positive 11x there. So I'm just going to write that as plus 11x because plus 12 minus 1. And then distribute that negative. So all of these are going to change sign. So I've got x squared minus 3x squared, which makes negative 2x squared. I have negative 5x minus 11x, which becomes negative 16x. I have negative 5x minus negative 4, so that becomes plus 4. Okay. The bottom, of course, is going to stay the same. Okay. And then from here, once it's all in one, that's when you would look to see if you have anything that would cancel. See if this top part factors or anything like that. Alright, so if I take a negative 2 out, I would get x squared plus 8x minus 2, and that right there is not going to factor, so nothing's going to cancel. So this would be my final answer. They may possibly multiply that bottom out. It just depends on what the answers look like and what format they want you to write it in. So that's how you would subtract. Adding is the exact same process, only you don't have to worry about distribution of the negative. The only other ones from 9.1.1 are those complex fractions, which is where you have the fraction top and bottom. So if I'm looking at a complex fraction, such as this thing, so 2 minus 2 over x plus 1, all divided by 2 plus 2 over x plus 1. So first things first is you want to get a single fraction on top and a single fraction on bottom, because right now I've got 2 terms in the numerator and 2 terms in the denominator, and we don't want that. We want 1 term on top, 1 term on bottom. So I'm going to get a common denominator up here. So I'll put that over 1. Alright, so here I need an x plus 1. I need the whole thing. So we're going to times by x plus 1, top and bottom. And here I need nothing because you don't really need the 1 in there. Okay, we're going to go ahead and do the same thing to the bottom at the same time. Alright, so this is over 1. So I'm going to multiply by x plus 1, top and bottom. Alright, so that I get that. So when I multiply the top here, I get 2x plus 2 over x plus 1 minus 2 over x plus 1. And we'll put those together in just a second. And that's all divided by 2x plus 2. Alright, distributing there over x plus 1 plus 2 over x plus 1. Okay, so next step, make those into single fractions. Okay, so here we go. So 2x plus 2 minus 2 is just 2x over x plus 1. Let me kind of help you differentiate between these things. Over, alright, 2x plus 2 makes 2x plus 4 over x plus 1. Alright, so now remember that a fraction bar is just division. So this is the same thing as saying, I'm going to kind of slide over here. So this is the same thing as saying, let me switch colors so they don't get confused. 2x over x plus 1 divided by 2x plus 4 over x plus 1. And this we just talked about. So I've got division, so we're going to keep the first, flip the second one, and then change it to multiplication. And then from there, right, x plus 1s can cancel. Again, be careful here. You can't just cancel the 2x's because this has a plus 4 attached to it. So when I multiply straight across, I would get 2x on top, and I would get 2x plus 4 on bottom. Now, one thing I can do is I can factor a 2 out of this. 2x over 2 times x plus 2. Well, the 2's are both factors because this is really 2 times x and 2 times this thing. So I can cancel 2's here. Alright, so final answer here would be x over x plus 2. And that's what that would look like. Again, can't cancel the x's because the x is divided by that plus 2 as well. Okay, so that's 9.1.1. So after that, it goes into all of the graphing, and there's a whole separate video for graphing, so I'm not going to go through the graphing at all. You can use the other graphing video to look at all of the graphing rational functions and finding all the asymptotes and all that good stuff. So next up, we're going to talk about simplifying radicals. So with simplifying radicals, we're looking at breaking these things down into perfect groups if possible, based on what the root is. So if I'm looking at something like, I think most people know how to do this one, square root of 288 right? So a lot of you guys, if you don't know the square root of 288, sorry, that's a little small. Let me write it a little bit bigger. Square root of 288, right? If you don't know the square root of 288, then you can go into the breaking down. If you don't know what goes into 288, it's even, so you know for sure that 2 would go into it, right? 144, and you just kind of go from there. If you don't recognize that 144 is a perfect square, then keep doing the same thing. You can just keep breaking things down until you no longer have a 9 times 3, until you can no longer break them down, right? So this is called prime factorization. So all the prime factors would be 2, 2, 3, 3, 3, right? And I try to cross out the ones that I broke apart so I don't accidentally put those back in. So since it's a square root, I'm looking for groups of 2. So I have 2 2's and I have 2 3's. Those come out of the radical and multiply together. So I would get a 2 times 3 out front. And then I have this 3 left over inside. All right, so final answer there, 6 root 3. So if I'm looking at something like the 6th root of 64, you can do the same process if you need to. Alright, so 8 times 8 makes 64, 4 and 2, 2 and 2. Same thing here, 4 and 2, 2 and 2. Right, so I've got 2, 2, 2, 2, 2, and 2. So since it's a 6th root, I'm looking for groups of 6. 1, 2, 3, 4, 5, 6. Okay, and there's nothing left over because everything else was broken down. So the 6th root of 64 is just 2 because I can get one group of 6 2's. Excuse me. Rationalizing. Most people were okay with the 2 over root 5. I'm going to talk about when it has something bigger on bottom. So we can't leave radicals in the denominator, and there's a separate little video that I posted as well on rationalizing, so if you need a lot more work with rationalizing, go watch that other video. But let's just say that I have, actually let's do this one, 5 cubed root of 16. So again, I'm looking for perfect groups. So if I'm looking at this, 8 and 2, 4 and 2, 2 and 2. A lot of you guys are trying to multiply 16 in 3 times, which you're another 2 times, so you get 3 of them, which is fine, but then you have to break things down. It's much easier to simplify as much as you can first, and then complete your perfect, in this case, cube. So I'm looking for groups of 3, so I have one group of 3 here. Alright, so that would come out first, so I would get 2 cubed root of 2. Now, in order to make a perfect group of 3, I would need 2 more 2's. So I'm going to multiply that in. Alright, so 2 and 2. So I have 2 more 2's that I'm multiplying in order to make a perfect group of 3. Alright, and then whatever I do to the bottom, I also do to the top. You don't have to write it as 2 times 2. You can just write the cubed root of 4. But that's the general idea, so that I have a perfect group of 3 on bottom, because now this would make the cubed root of 8, which would be 2. Alright, because I have 1, 2, 3 2's. So on top, I get 5 cubed root of 4, and on bottom you have this 2 that we already had times the cubed root of 2 times 2 times 2, which is going to be 2, right? Because that's a perfect group of 3 that I would take out of that cubed root. So final answer would be 5 cubed root 4 over 4. Okay, so that's kind of what that looks like when you're rationalizing. If you have something that's got like negative exponents and all that kind of stuff in them, let's look at one with variables real quick. Since we're looking for perfect groups, right, with the variables, it's really just a matter of division, because you're trying to figure out how many perfect groups of 5 I can get out of 30, because this really means m multiplied 30 times. So I have 30 m's available here. So how many groups of 5 can I get out of 30 m's? Well, I could get 6 groups of 5 out of 30 m's, right? So 5 divided into 30 just gives you 6. So I can get m to the 6th power, and there is nothing remaining there, because 5 goes into 30 evenly 6 times. So you get m to the 6th power. Now 5 does not go into 32 evenly. It does, however, go in 6 times. So I could get 6 groups of 5 out of the 32, so k to the 6th power, and then I would have 2 k's left over, right? So k squared. Because again, k to the 32 means k multiplied 32 times. So if I'm looking for groups of 6, or groups of 5, I could make 6 groups of 5, and then I would have those 2 k's left over, so k squared, because k times k makes k squared. Alright, so with the variables, it's easy. You just divide them. Divide the root by the exponent. Super simple there. Let's see. Power to a power you multiply. You need to kind of review your exponential properties. If you don't know how to do those, there's a whole separate video that goes over exponential properties, so I'm not going to go real deep into that. If you have something like this, keep in mind that in order to add or subtract radicals, the radical and the root have to be exactly the same. So you would need to break these down first to see if they break down to be exactly the same. So like 254, and then 9 times 6, and then 3 and 3, and then 3 and 2. Alright, so I have a group of 3, and I have 2 2's left over. Alright, so you'd multiply those back together. So this should be 3 cubed root of 4. Do the same thing here. Alright, 8 times 4, and then 4 times 2, 2, 2, 2, and 2. Alright, so I have a group of 3, and then I would have 4 left over. So this 2 that comes out will multiply by that number that's already out front. So I would have 10 times 2, which would make 20 cubed root, and then there's 2 times 2 left, which gives you 4. And then last one, same thing. 5 times 100, alright, 10 and 10, 5 and 2, 5 and 2. Alright, so I've got 1, 2, 3 5s, and then I've got 2 2's left over. So that would be 5 cubed root 4. Okay, and then once you're here, all of my roots and my radicals are exactly the same, cubed root 4, cubed root 4, cubed root 4, and you just add the coefficients out front. So 3 plus 20 is 23, plus 5 makes 28 cubed roots of 4. Okay, so that's what those will look like. Last one here, and then we'll move on from this section. Be careful with stuff like this. Right? Do not distribute the square because you have a minus sign in there. You have to actually multiply this out. Right? So minus 3 times 2 root 5 minus 3. Alright, so FOIL 2 root 5 times 2 root 5. When we multiply radicals, the numbers out front multiply and the numbers inside multiply. So 2 root 5 times 2 root 5 would be 2 times 2, square root of 5 times 5. We'll simplify this in a second. Right, and then minus 3 times 2 root 5. Inside, minus 3 times 2 root 5. Outside, negative 3 times negative 3 makes positive 9. Okay, so here, 5 times 5 inside, well, that's the square root. We already have a group of 2, so that's going to come out. So we'll have 2 times 2 is 4 times 5, which would make 20, right? Because the square root of 25 here is 5, so 2 times 2 times 5 makes 20. And then I've got negative 6 root 5, negative 6 root 5, which makes negative 12 root 5s. Okay, because the root and the radical are exactly the same. Okay, the root and the base. And then plus 9. So final answer would be 29 minus 12 root 5. Okay, so that's what that looks like. If you want to rationalize with a radical on bottom, or with a few things on bottom, so we already talked about rationalizing, but if you have something like this where you have a plus or minus on bottom, you use that conjugate. Sorry, let me slide that over. Alright, you use a conjugate, so square root of 7 plus square root of 3. I would multiply by the square root of 7 minus the square root of 3 to top and bottom. Alright, purpose being so that when I multiply when I FOIL out the bottom here, the radicals will go away. So I'll get the square root of 7 times the square root of 7, which will just be 7, because you'll get the square root of 49. This would be minus root 21. This is plus root 21, so those cancel. And then positive square root of 3 minus the square root of 3 becomes minus 3. Okay? Because square root of 3 times square root of 3 makes 3. On top, they might ask you to distribute. They might not. You just have to kind of look to see what all they do there. So 4 root 7 minus 4 root 3, that's a possibility. Or they might have just left it like this. There's going to be another step, so I know that this one right here is going to end up canceling. So when on the bottom, 7 minus 3 makes 4. Alright, so if I leave it like this, sorry, that's just square root of 3. Right, this is multiplication, so since it's multiplication, I'm allowed to cancel those 4. So it would just be the square root of 7 minus the square root of 3. That bottom won't always cancel, that's special to this particular problem. But that's how you deal with rationalizing when there is a number on bottom. And then last thing from that section, I was wrong, I thought we were done, but we're not. You do need to go look at exponential properties, but I'll do one of these just to kind of talk about it. So like if you have something like this, 12th n to the 7th, all over 5p cubed n to the 5th, and it's all being raised to the 6th power. Remember that since all of it is being raised to the same exponent because of these parentheses here, you can reduce inside first. It'll make your life way easier. So like 10 and 5 reduces to 1 and 2. Remember when you're dividing variables, you subtract exponents. So I would minus 3, and here I would minus 5. So I end up with a 1 in the denominator, so it kind of goes away. And I end up with 2p to the 9th n to the 2nd, all raised to the 6th power. So now we can distribute this exponent because there's no plus or minuses in here. Keep in mind that the number also gets raised to that power, but it's 2 to the 6th power, right? So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 would make 64. So you would get 64, and then power on a power you multiply. So 9 times 6 is 54, and 2 times 6 makes 12. That's an n, sorry. Okay, so that's the general idea. Again, if you need more help with exponential properties, there's a whole video on them on Google Classroom that I posted that you can go and check out. Okay, for the sake of the length of the video, I'm going to go ahead and break this up. So I'm going to stop there, and then I'll make a second video over 9.3.2 and on. So I'm going to go ahead and stop that video there, and there will be a part 2 in a little while.